Hey everyone, welcome back to another video. So today we're going to be going over all the content you need to know for Unit 1, Basic Economic Concepts for both AP Microeconomics and AP Macroeconomics, depending on the video you're watching, because the first four topics are the exact same, okay? So let's just dive right into it. So we got topic 1.1, which is scarcity, okay? So this is sort of the underlying principle for economics. So scarcity is essentially the idea that we have unlimited wants but limited resources. Now, the more textbook definition is that we do not have enough resources to produce all the goods and services that people want at zero cost. And that last part is the key. And so when we talk about scarcity, we have limited resources, right? We have planet Earth and there's limited resources. We can't just create products out of the air. And therefore, because of that, every single choice that we make has a trade-off, okay? If you choose to go to college, you're giving something up, right? You're giving something up as in you couldn't do something else, okay? And that specific trade-off is called a opportunity cost, and that is your next best alternative. So if you went to college, you're trying to get a degree, right? That's sort of like the gamble you're taking. But then your opportunity cost or your next best alternative, you could have gone to trade school or entered the workforce immediately and started making money like that, right? So that is your trade-off and your next best alternative. Now let's talk about topic 1.2, which is resource allocation and economic systems. Okay, so we know we have scarcity, and because of scarcity, we have limited resources. But more specifically, these limited resources can sort of be boiled down to four factors of production which you need to know for economics. That is land, pretty self-explanatory, labor, just people working, entrepreneurship, which is somebody to put everything together, and the capital, so you have human capital, which is just the knowledge that people have, and skills, and then you also have physical capital, right? So more like machinery and tools that people use to create products or create goods and all that kind of stuff. And so when you have limited resources, you really have limited factors of production. You have limited land, you have limited labor, you have limited capital, etc. And so the question arises is that how do you distribute the land, labor, and capital among all these people, right? So what kinds of goods and services should we produce? How should they be produced? Who should consume these goods and services? And so as a society, right, as a whole, there is two main sort of economic systems that have arisen. And those are a free market economy, which the resources are dictated by the individual, or you have a command or centralized economy, which the resources are dictated by a government. So here's a nice Venn diagram that shows you the key differences between a free market and a command economy. So a free market economy, stuff like private businesses, little government intervention. So think capitalism, okay? And the key point here is that the individuals own the resources. When you talk about a command economy, talk about, communism. It's not the exact same thing, but they go hand in hand. You got little private property, very heavy government regulation. Key important thing, government owns the resources. And you got some other economies that are like a mix between the two. Have a mix of government intervention and all that kind of stuff. Okay, just a balance overall. All right, so the next topic we're going to be talking about is topic 1.3, which is the production possibilities curve or frontier. Okay, so the PPC or the PPF is essentially a graph that will show you how efficient the production is, right? And also shows you the alternative ways that you can use your resources, your scarce resources more specifically, to produce certain amounts or units of goods. So the first type I want to focus on is constant opportunity cost, okay? So you can see here we have shirts and pants, okay? You have the production of shirts and the production of pants. You can see as we produce more shirts, we're giving up pants, okay? That's opportunity cost, right? You're always giving something off when you make a choice, right? So if we want to produce shirts, right? If we go from A to B, we're producing one shirt, right? One shirt produced at the cost of two pants. Okay, we're losing two pants, but we get one shirt in exchange for that. And so you have constant opportunity cost when the products use similar resources. Okay, so shirts and pants both use fabrics, and so you have constant opportunity cost there. But what happens when they use very different resources? Well, this is when you have increasing opportunity cost, right? So if we're talking about pencils versus shirts, you can see that when we go from A to B now, we create one shirt, right, at the expense of 3 pencils. But now when we go from 1 to 2 shirts, we have the same 1 shirt increase, but because the products between shirts and pencils use very different resources, right? Shirts use fabrics, pencils use graphite wood. And so that drastic change is going to mean that that opportunity cost is going to be increased. So you can see here that instead of losing 3 pencils now, we go from 47 to 41 pencils. That's 6 pencils. That is literally double the number of pencils we've lost. And from there, it just keeps increasing. So how exactly do you calculate opportunity cost? Well, it's pretty simple, right? So using this chart we have on the left as an example, if we go from A to B, we produce 1 extra shirt. What do we lose? Well, then we go from 50 to 47 pencils, so we give up 3 pencils. Going from C to E, same idea. We gain 2 shirts from 2 to 4, but we go from 41 all the way down to 5 pencils. So we lose 36 pencils. From D to A, this is going backwards, so now we're gaining pencils. We gain 31 pencils, but in the process, we go from 3 to 0 shirts, and therefore we lose 3 shirts, and that is our opportunity cost. All right, that's good and all, but we know that our basic principles here of scarcity, trade-offs, and efficiency, how exactly are those shown on the production possibilities curve? Well, it's pretty simple, right? You got scarcity, right? The curve literally shows you the maximum production, right? So scarcity is shown because there's limited production. The curve shows you the most efficient way you can use your resources and the most amount of a certain product you can produce given the amount of resources you have. Then there's also trade-offs. Pretty simple here, right? You can see in the example up here, when shirts goes up, pencils goes down, and vice versa. So good A going up means good B will be going down because there's opportunity cost over there. Now, efficiency, okay? So this is something new, but pretty brief that I think you'll pick up on pretty easily. So you got a inefficient point, which is basically any point inside of the curve, okay? And then a point that is exactly on the curve is going to be maximum efficiency of your resources, producing the most amount of products as possible. And then we know scarcity, right? That curve represents the maximum efficiency. And so anything outside of that is impossible given the amount of resources we have to utilize right now. Here's the thing with graphs is that graphs can shift, okay? So the PPC can shift based on a most commonly change in resources, change in technology, or really any change in the 4 factors of production. Okay, so the PPC essentially shows you, or the shifts in the PPC show you an increase or decrease in production possibility. Okay, so if we're talking about the production possibility of shirts versus pencils, and we get an increase in the amount of resources we have for pencils strictly, what happens to the curve? Well, it goes to the right, right? We're shifting to the right. And so now at every single point of shirts, we have more pencils. And so we're pretty much giving up less pencils because we can produce more pencils, okay? And notice how the curve only shifts to the right where it pivots strictly for the pencils and not the shirts. And that's because only the pencil production increases. If we have an increase in resources specifically for pencils, that means we're getting more graphite, wood, and stuff like that instead of fabrics, right? If fabrics don't increase, or the wool or whatever for shirts, right, the production possibility for shirts stays the exact same. Now, if we have an overall decrease in the labor force, that is one of the key factors of production, right? So if labor decreases overall, that means both the production possibility of both shirts and pencils will decrease. And so the entire curve shifts inward. This last example is a trick question, right? So if people want more shirts, what happens to the curve? Well, nothing actually happens to the curve because we do not have a change in resources, change in technology, or change in any of the 4 factors of production. This is simple demand and supply, right? If we have people wanting more of a certain product, that means production is going to shift in a way that accounts for that. So if people want more shirts and we have a point on the production possibilities curve, it is going to shift upwards towards shirts, right? So now we produce less pencils, but more shirts to accommodate for the increased demand in shirts. So now we're going to be moving on to topic 1.4, which is comparative advantage in trade. So first off, let's get a couple terms out of the way. Absolute advantage is the superiority of the entity to produce a particular good. Okay, so that's just basically whoever produces more of something. So if I have Bob and Jack, Bob produces 5 apples, Jack produces 2. Bob, 5 is greater than 2, so Bob has the absolute advantage in terms of producing apples. Comparative advantage is a little more complex because it's basically who has advantage in opportunity cost. Okay, so who can produce goods at a lower cost than others, right? So if you're producing the same good, who is going to be losing out on less of a particular good or trade-offs, okay? So this will make more sense when we talk about the 2 main types of questions you need to know for comparative advantage in trade, and that is output questions and input questions. So output questions is essentially where you have a chart or a table, and it shows you the finished products, and it's basically the result of the input, which is the resources, right? So this is pretty much the production possibility of David and William. So David can produce 6 pies and 4 cakes. William can produce 4 pies and 2 cakes. So if I ask you who has the absolute advantage, well, David has the absolute advantage in both pies and cakes because 6 is greater than 4 and 4 is greater than 2. So now if I asked you who has the comparative advantage, right? So now you want to calculate the opportunity cost. Try and go ahead and calculate the opportunity cost for both David with his pies and cakes and William with his pies and cakes. All right, so now in order to calculate this, we need a formula, okay? You don't need a formula, but this makes it super easy to think about. So if we want to calculate the opportunity cost of a certain good, let's call it A, that's going to be equivalent to the total of good B over the total of good A. This is specifically for output questions, okay? So moving back to this example, if we want to calculate the opportunity cost of David and his pies, right? What is the opportunity cost of David to produce 1 pie? If he produces 1 pie, what does he give up in terms of cakes? Well, we know that opportunity cost of A equals total of B over total of A. And so the opportunity cost of David and his pies means that pies is good A, right? Because that's what we're trying to find the opportunity cost for. So now we need to find the total of the other good, which in our case is cakes. And so now cakes is essentially good B. So find the total of that. We can see the total here is 4. And we just set it over the total of A. So our total of A here is David and his pies at 6. So 4 over 6 is a 2/3 ratio or a 2/3 fraction. Therefore, our opportunity cost there is 2/3 of a cake. Now we do the same thing for David and his cakes, right? So what is the opportunity cost of David producing 1 cake? If he produces 1 cake, what does he give up in terms of pies? So now cakes is the good A, and therefore we need to find the total of B. The total of B, good B in our case now, is pies. So we have 6. Now we need to just set 6 over 4. 6 over 4 is 3 halves. You can see here that they are reciprocals of each other. So if you find one, you can just take the reciprocal of its value to find the opportunity cost of the other one. Same thing for William, right? So we have pies here. We have 1/2 of a cake. Why? Well, we're just using this formula. So pies here we have is good A, so that's 4. And so now we know we need the total of B, the other product is cakes. So cakes is 2. 2 over 4 is 1/2. Now we can just take the reciprocal of that. Super nice and easy. When he produces 1 cake, he gives up 2 pies. Okay. So now when we talk about comparative advantage is who has an advantage in terms of opportunity cost. Who gives up less for producing that product? So when we're talking about pies, who produces 1 pie at the lowest cost? Well, we look at David. If he produces 1 pie, he gives up 2/3 of a cake. William, he can produce 1 pie, only give up 1/2 of a cake. Therefore, William gives up less cake per pie, and therefore he has a comparative advantage in producing pies. Same thing for cakes, okay? So now we're just looking at how much they give up for producing 1 cake. David, producing 1 cake, gives up 3 halves of a pie. For William, he gives up 2 pies just to produce 1 cake. Therefore, David has the comparative advantage in terms of cakes. Now let's talk about terms of trade, right? So if I were to trade let's say we had David and William trade, right? So let's say we gave up one cake for how many pies, right? So what is the ratio here that would satisfy both William and David? Well, David is the one giving up the cake, right? Because we know he has a comparative advantage in cakes, okay? He can produce cakes at a lower cost than pies. So William now has to find a ratio that makes not only him happy, but also David happy so that David would agree to the trade. And we can see this pretty simply, right? If we look at the opportunity cost of both William and David for producing one cake, you're going to see a pattern. So for David here, if he produces one cake, he gives up 3 halves of a pie. For William, if he produces one cake, he gives up 2 pies, okay? So we have pretty much a range of values, okay? We have David with his 1.5 pies, William with his 2 pies, okay? So David, in our case, we know that he gives up one cake for 1.5 pies. And so if he is able to get anything greater than 1.5 pies for his one cake, he's going to be happy. For William, on the other hand, he gives up 2 pies for every single cake. Therefore, if he can get one cake for less than 2 pies, he's going to be happy, right? Because he's giving up less for essentially the same thing just because he didn't produce it. He found somebody else, David, to produce it at a cheaper price. So because our opportunity cost here for cakes is between 1.5 and 2 pies, we just need a value in between 1.5 and 2 that satisfies both sides. In our case, that is 1.75. All right, so now that we've dealt with output questions, we have a very similar concept in input questions. So input questions is essentially, it refers to like resources like fuel and labor that you have to put in to produce a certain good. So in our case, we have the number of hours it takes to produce each good. So for David, it takes 6 hours to produce one pie, 4 hours to produce one cake. For William, it takes 4 hours to produce one pie, etc. So when I talk about who has the absolute advantage in producing both pies and cakes, it is going to be William, right? Because William literally takes less time to produce both pies and cakes. Now, if we're talking about opportunity cost, here is the other formula. We already had a formula for output questions, but the formula for input questions is pretty much the same thing, but flipped, right? So the opportunity cost of A is going to be equivalent to the total of A over the total of B. So what does this look like in action? Well, pretty simple here. Let's find the opportunity cost of David and his pies, right? So we know pies is good A, so we just find the total of A, which is 6, over the total of B. Good B here is cakes, so 6 over 4, which simplifies to 3 halves. Now we take the reciprocal of that, which is 2/3, and we've just solved that problem in 10 seconds. Same thing for William. Let's find his opportunity cost with his pies, okay? So William pies is good A, so 4 over 2, because cakes is good B. 4 over 2 is 2. 2 cakes is his opportunity cost. Take the reciprocal for the other good, and we have 1/2 pie for 1 cake. So who has a comparative advantage? Well, let's see, pies, okay? David, if he produces 1 pie, he gives up 3 halves of a cake. William, on the other hand, if he produces 1 pie, he gives up 2 cakes, okay? So clearly David is able to give up less for producing 1 pie. And so the other guy now, what does he have an advantage in? Well, he has an advantage in cakes, okay? Because if David produces 1 cake, he gives up 2/3 of a pie. William, he only gives up 1/2 of a pie for producing 1 cake. William has the comparative advantage in terms of producing cakes. So now let's do the same thing. What is an acceptable terms of trade? Let's say we had 1 cake for how many pies? Well, here is your answer, right? We need to establish who is trading what. Because William has a comparative advantage in cakes, he's going to be the one supplying the cake, okay? David is responsible for producing pies because he has a comparative advantage in pies. So now David has to produce a pie amount that he's going to trade to William that benefits him, but also benefits William. So if you look at David, his opportunity cost for producing 1 cake is 2/3 of a pie. For William, his opportunity cost is 1/2 a pie. So William is going to be happy if he gets anything greater than 1 pie. William is going to be happy if he gets anything greater than 1/2 a pie for his 1 cake, right? Because he's essentially making, more than that, essentially. Now, if you have David in his 1 cake, if David produces 1 cake, it would cost him 2/3 of a pie, right? And so he doesn't want to give up 2/3 of a pie. He wants to give up less than 2/3 of a pie. So if William wants anything greater than 1/2 of a pie, David wants anything less than 2/3 of a pie, just find a number in between that. That's our ratio there. So we have 0.6. That satisfies both sides. Everyone benefits because they have a comparative advantage for producing a certain good. So now we're going to be covering the final two topics in AP Microeconomics Unit 1. That's going to be topic 1.5, cost benefit analysis, and topic 1.6, marginal analysis and consumer choice. All right, so let's first define explicit costs. Okay, so explicit costs are essentially just cold hard cash, right? And they're out of pocket and they're basically actual monetary things. Now, implicit costs are much more subjective, right? And these are usually attributed to things like opportunity costs. So if we're thinking back to like the college aspect, you're giving up something like you're giving up the opportunity to go right into the workforce, to go to college, right? So now we also have what we call utility or benefit, right? So this is basically the level of satisfaction or benefit that you arbitrarily get from something. And we measure that with a fake unit called utils or utilities, okay? And the big thing behind this is that there is the law of diminishing marginal utility, okay? Basically, if you do something for a while, you're gonna get less and less from it, right? You're gonna be less and less satisfied from each consecutive product or each consecutive, say, slices of pizza in our case. So the first slice of pizza that you eat might give you 10 util. Okay, that just measures the amount of satisfaction. But then the second pizza you eat might give you half of that, right? 5 util. Third pizza gives you even less, okay? So the satisfaction from each additional unit of a certain product or service will decrease as you consume more. So we just want to understand conceptually in topic 1.5 the idea of utils and diminishing marginal utility, okay? So here I have a graph. And let's just say we were talking about pizza slices, okay? So that cost / benefit is going to be either the cost of that pizza or the amount of benefit you get from the pizza, right? That satisfaction. And on the x-axis, we just have the quantity, right? So the number of slices of pizza you eat. You can see that when quantity is low, that means the first couple of slices of pizza you eat, the marginal cost is low, right? It's lower than the marginal benefit. But the thing with this is that eventually you're going to hit a certain point called the benefit maximizing quantity, okay? So basically at this point is where you no longer want to consume more of that product or service because you're actually going to be hurting yourself in terms of utils or satisfaction than getting a net profit or net positive there, right? So once you go past a certain point, because marginal cost increases now, and marginal benefit, as we talked about before, decreases as you consume more, you're actually going to get a net negative, right? You're actually going to be losing satisfaction from each additional slice. If you eat 20 slices of pizza, you're going to be losing out because not only are those slices of pizza going to be costing you, real money to get, but it can also have some negative health benefits, right? So just evaluating that in sort of a conceptual, qualitative thinking, okay? So we also call this the cost benefit maximizing principle, right? So we want to pretty much consume that product or service up until a certain point until the marginal cost is equivalent to the marginal benefit, at which point we want to abandon that, okay? Because everything past that is simply negative. So when the marginal benefit is greater than the marginal cost, keep consuming that product or service. That's a good thing because you're getting satisfaction. But if it's lower, that's bad because you're literally putting yourself in a deep hole where you're losing stuff. Okay, that's cool and all, but with topic 1.6, we want to understand it in terms of actual numbers and problems, okay? So how do we maximize utility between certain goods? If we have two goods, how do we maximize the amount of satisfaction we get from them? Well, this is where we come to the utility maximizing rule. It's pretty simple. You got marginal utility of 1 over price of 1 equals marginal utility of 2 over price of 2. The marginal utility is just the utility that you get from each consecutive pizza slice or each consecutive consumption of a product or service, not your total utility, right? Because we know that total utility is obviously going to increase to a certain point, but marginal utility decreases as you consume more of a product. So the idea here is that we want to maximize the marginal utility per dollar. Let's say I went on a vacation, right? that's gonna give me super high marginal utility, but it's gonna cost me a bunch, right? So when you take that per dollar value transaction, that's actually gonna give you less marginal utility per dollar than originally that you might have thought, right? So you have to think about everything in terms of money and all that. So if we had a problem here, if the budget given to Sam at the local county fair for food is $18, what would be the combination of hamburgers and soft pretzels that would maximize his utility? Okay, we can see that hamburgers and soft pretzels, they've already calculated the marginal utility and marginal utility per dollar for us, but if they didn't, it's pretty simple to do so. Let's say we're looking at hamburgers, right? So we got quantity 1, we get 12 total utility from that, okay? And so we eat one hamburger, we get 12 utility. Now, if we eat the second hamburger, we're only gaining 8 marginal utility. So that second hamburger gives us 8 marginal utility. And so now our total utility is 12 plus 8 equals 20. And the marginal utility per dollar is also straightforward. It's simply your marginal utility divided by the cost of the product. So if we're looking at me eating one hamburger, my marginal utility there is 12 utils, okay? And the price of a hamburger is $2. So 12 divided by 2 equals 6. So I get 6 marginal utility per dollar I spend. Let's go back to the problem, okay? If the budget given to him is $18, what would be the combination between hamburgers and soft pretzels that would maximize his utility? We want to maximize utility in terms of dollars, right? Remember, the utility maximizing rule, we want to maximize the marginal utility per dollar. So it's pretty simple. You just want to look at the bigger numbers. So if I'm looking at this chart here, the biggest number right now is 8. Okay, so that means the first thing I need to do with my money is buy one soft pretzel. So if I have $18, I spend $3. Now I have $15. Okay, now if I'm looking at the other numbers, the second biggest number is 6, right? I can either eat my first hamburger or buy my second pretzel. Okay, both will give me 6 marginal utility per dollar, so it really doesn't matter which one I do. And I'm just going to keep doing this until I spend all of my money, right? I do this entire process, right? You can see I buy my soft pretzel first, then I buy one hamburger. Then I buy that second soft pretzel, and then I have a tie, right? I can either get a second hamburger or a third soft pretzel to give me the same marginal utility per dollar. And I just do this process until I hit that $0 and spend my entire budget. So now you can see that we have a final answer of 3 hamburgers, which you can see on the left side there, and 4 soft pretzels on the right side there, where I spend all my budget, right? I spend my entire $18 budget, and I also maximize my marginal utility per dollar going down, right? I'm getting the most bang for my buck here. I'm getting the most satisfaction in terms of marginal utility. So that does it for the entire unit review for AP Microeconomics. If this video helped, make sure you subscribe, and I'll see you guys in the next video.